The last thing that I want to do as we wrap up this first design intent study for parts is to look at a special sort of design intent, which is design for machining. So our traditional steps of building a part would be to add material first and then to make our cuts at the end. But in design for machining, what we actually want to do is try to simulate the machining process through our modeling. And by doing that, it helps us as an engineer understand, can I make this part? How would I make this part? And it provides some guidance for the machinist as to what we were thinking as far as making the part. And it's always a little bit dangerous perhaps to try to suggest to a machinist how to make a part. It's a great way to make yourself look stupid, but as an engineer, this, at least designing for machining, producing a CAD drawing to design for machining, helps us kind of understand how to think about building and making a part. So let's take a pretty simple example. We have a bolt here. It's got a shank on it that is a different size from the threaded portion, and depending on the sizes, this might be a custom part. I have a part like this for my tractor, and I just cannot find this bolt anywhere, and so when it breaks, well, I can order it from the manufacturer. It's a very expensive bolt, about 20 bucks. Someday I'll have to figure out how to machine one of these things. But let me flip over to our SolidWorks file, and I've already got this drawn in a SolidWorks file, and so this is the finished product. And what I just want to look at real quick is how I created this, because it's different from how I've been creating everything else. And so I've got all my features indicated here, and so as I roll back the drawing, so I just grab this bar and I can roll it back to the top. What I'm going to do is I'm going to start this with a piece of generic round stock. This is 1-inch round stock, and as I machine the part, I want to think about what are the steps. So the first thing that I think I want to do is cut out the bigger shank, and so put it on a lathe, turn it down to the proper size, and then from there I'm going to cut out the smaller shank that I'm going to put the threads on. After I do that, I'm going to actually cut the threads into it. And typically on solid modeling we would use cosmetic threads because these take up an incredible amount of memory, but just the challenge of adding threads was more than I could resist, quite honestly. So I did. And then the last thing I'm going to do is pull it out of the lathe once I've got all the lathe operations done, and I'm going to cut the flats on the head with a milling machine. And there I have the complete part. And so basically, again, the key thing here is I've started with a solid, and everything I've done is a cut, 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 and cut. And so I haven't done any adding material. And again, the goal is to try to simulate the machining steps. Just even if the machinist doesn't use this, for myself as an engineer, I can kind of verify and say, okay, I think this can be machined, and I don't think it's going to be too hard to machine because I did all of these steps and they seem to flow pretty naturally. So that's a different type of design intent, and that's designing a part and trying to simulate your manufacturing steps through your design and through your CAD model.